Well, since I've been posting these videos about my heat pump, a lot of the comments have been how complicated everything seems. So today I wanted to try and demystify the system a little bit and show you actually how simple it is. And in fact, most of the components are the same or equivalent to a gas central heating system. So I'm going to run you through the schematics. It's probably not going to work very well for you if you're on a small phone screen, so this probably going to be you're probably going to need to watch it on a bigger screen to be able to make out the different components. But I'm going to try and speak about it as simply as possible. I'm just a homeowner, an enthusiast DIYer, but I'm not a qualified engineer, and everything to me is pretty straightforward and seems pretty simple. So if I can stop hitting my microphone, then let's get on with the video. I'll insert a load of clips of my own system, so you'll see actual pictures of what it looks like as well as the schematic anyway. So let's start off then. Should we go in numerical order or should we start with the big items? Why don't we go here? Item number two is the heat pump itself. And in my case, it's a Vaillant Arotherm Plus. It's a monoblock unit. That means that the heat exchanger is inside the unit, so there's no refrigerant lines running into the house. So you can see here, the red line is the hot water or the feed, and then the blue line is the return. Cooler temperature, normally somewhere between 5 to 7 degrees cooler than the red feed that's coming out of the heat pump. And you can see the various layouts, and this is my specific layout. So you see in this document there's eight different configurations that Vaillant kind of support and recommend, and within those 8 configurations then it's broken down into different multiple radiator zones and underfloor heating, etc. Mine is the simplest of the simple. It's number one radiator zone. The only thing I have is what they call a decoupler or a buffer, so that gives us some hydraulic separation, but I can go into that a little bit further down, and hopefully this is easy for you to understand because I'm explaining it as a layman to you others that are laymen as well. Yeah, that's a good term. Okay, let's go then. So number 2 is the heat pump. Number 3 is a secondary circulation pump. So this particular one, you can see here, this is showing hot water and back round into the cold feed of the hot water tank. In my case, I don't have a secondary circulation pump. In some larger houses, you may need that, and what that will do is that will stop you needing to run the hot water tap for so long until the hot water comes out. Probably not the most efficient way, but it will also prevent stagnant water sitting in long runs of hot water pipe work that isn't used for a long time. So anyway, let's jump off of 3E and let's go for 3F. 3F in my case is the primary pump. This is the pump that circulates the water around my radiators, and we'll come down to 10 later because I'm trying to do it in numerical order just to keep it simple. But here you can see the hot water coming into the pump and pushing the hot water around the radiators, just like any other central heating system. The same actually with a secondary circulation pump. You might not have one, I don't have one, but that's not a heat pump specific item. Number 5 is the hot water cylinder. Here you can see a normal looking cylinder, and it is essentially the same as any other cylinder apart from one difference. This has a larger coil running through it, so the hot water that comes in runs through a much larger volume coil than you would typically have for the equivalent cylinder for a gas boiler system, and that's because of the low temperature heating, so that it has more surface area to heat it in the similar way that you have larger radiators, so you have larger surface area so you can run at a lower temperature and be more efficient. the hot water cylinder needs to be specified in exactly the same way. Okay, so number 7 is my buffer tank. Now, I have a buffer tank, and it's positive for a few reasons and it's negative for a few reasons. It will rob you of a little bit of efficiency. In my case, I'm not seeing that it's robbing a huge amount of efficiency so far, but we'll see. I keep monitoring this and we'll see how it goes. But you can see basically the hot water comes into it and hot water goes out of it. The cold water goes back in and feeds back out. And so in my case, this one is a 45 litre tank. Flash it up on screen now, and all that is doing is separating the flow rate of the heat pump to the rest of the central heating system. Now, this again is not necessarily specific to heat pumps, although it's much more likely that a heat pump will be fitted with a buffer tank than a gas heating system. And that's because the heat pumps, because they're flowing at such a low temperature out of the feed pipe, they need to flow a lot more volume, a lot more quickly than a gas heating system would have to. Now, our existing radiator system may not be able to keep up with that flow. For whatever reason, there may be some restrictions, and so we have a secondary pump here that will pump at the correct rate to maintain the difference between the hot and cold flow and to get the correct amount of heat to each of your radiators. And in your case, you may have multiple pumps for multiple zones, different flow rates needed for underfloor heating, in comparison to radiators. There's a lot more detail you could go into this, and the real specialists, they'll calculate your flow rates and they'll try and match everything perfectly so that you need as little pump intervention and other things like buffer tanks, and there's other hydraulic separation devices that can also work to increase the efficiency. So why can a buffer tank be optimal? Well, it can help with the flow rates, but it also helps when we come to a defrost cycle, having that extra volume. In my case, I'm finding that the heat pump isn't defrosting as much as I was as expected. So maybe it's because when we get the very low temperatures, the humidity also drops, and you need to have the combination of cold temperature and higher humidity to really attack the heat pump with a frost. So anyway, I digress. I'm going to have to cut loads of this rubbish out of the video. I've hardly covered anything. So 8, we've got heating and domestic hot water expansion vessels over here, so you'll be familiar with that, especially if you've got any kind of pressurized system. If you don't have one of these, you may have a combi boiler that has an expansion vessel built into the combi boiler, but you still have one. Larger systems will typically always have one wall mounted, and we've got one for the domestic hot water and we've got one for the central heating, so one on each side of the system, and those are both, as you can see, both plumbed in on the return as well, so they are not on the primary hot side of it. So where are we going after that? So that's number 8. So number 9, which one are we going for first? 9R is the isolation valves, and that just helps if you need to disconnect the pump outside. Don't need to completely drain down the whole system, or vice versa, I guess. And so always good to have those isolation valves fitted for any maintenance work or anything else. So that's 9R. 9G is the main diverter valve. So as the hot water comes in, by default it will be set to B, and I'm sure it's just A and B, but you can see the black is showing the default line there. So if it's not powered up, that diverter valve will always send the hot water into the buffer, which is easy to remember, B for buffer. A will then go to the domestic hot water cylinder, and that will only engage if that is if that's powered up. So with no power, that will default to the buffer. And importantly, this diverter valve is not like some of the other three-way valves that you may have in your central heating system. Previously, our old three-way valve, it could do hot water and it could do heating at the same time. That's not good for a heat pump, especially as the hot water you want to be heating up to 50 degrees, and typically our radiator hot water temperature is 30 degrees. So to get the cylinder to 50 degrees, you may be running the heat pump flow temperature at 60 degrees. You don't want that 60 degrees running around your radiators and massively overheating your house. So it will only do one at a time. So that's 9G, that's the three-way valve, the diverter valve. 9H is the fill and drain valve. Where did they put that on this schematic? Oh, here you go. Right by the expansion vessel. Same in mine. I'll show some pictures. It's just a normal fill-in loop. And again, unless you've got a gravity-fed system, this is just a normal component. You'll have this on any gas heating system. 9J is the expansion vessel service valve. 9J. Yeah, so this just, again, this is a typical valve that would be used with a gas heated system as well, just for servicing your expansion vessel, and can, as you can see, is typically open in all directions. 9R is an isolation valve. We already did 9R, didn't we? I jumped the gun. 10C is non-return valve. Let's hunt out 10C on our schematic. Here you can go. So that will just stop. In my case, I don't have this again, but this will make sure that your hot water is only flowing one way, that there's no chance of it flowing back and pushing the cold water back through, because as cold water comes in here, it could potentially push back against this. So they've put a safety valve in there to stop it. Again, this is not heat pump specific. 10E is a Y strainer, so this is fitted on the return, and as you can see, that is just if there's any debris in the pipes. That's essentially a filter that is both on the on the return for both the central heating and the hot water side. You'll notice that's 10E. If we jump over to 10J, you'll notice this is a magnetic filter. So you've got both the strainer protecting the pump, and you've got magnetic filter on the rad circuit side of things as well. So in my case, 10J is not fitted on this side of the buffer. 10J is actually fitted in the 10E position. And so I have 10J that is a magnetic filter, but it's working on the return for both the central heating and the hot water side. Let me know if that's a good thing or a bad thing. I'm not experienced enough, and like I say, I'm just an enthusiast, just an amateur. 10I is the flexi hose connections. These are pretty important because right there is the compressor, and you don't want the compressor rigidly mounted onto solid pipes that are not only going to be fixed onto your walls, but you're going to have these pipes connecting into all the pipework running throughout your house. So you want to try and absorb and isolate as much of the vibration as you possibly can. So the flexi hoses there are critical. Okay, number 11 on the tank is the immersion heater right here, number 11. There's nothing more to say. It's a standard immersion heater, no more, no less. Right, number 12. So number 12 is what we call the Senso Comfort Controller. You might call it a thermostat, but it is, in my case, not working as a thermostat. We don't use any of the indoor temperature to influence what the heating system is doing. 12P is the wireless receiver. So this one connects to my Wi-Fi, and that's how I can connect my app. 12B is the main heat pump interface. So there is some confusion as to why there is both, but essentially 12B would be like the controller that you originally have on your old gas boiler on the front main screen of it. If it's a modern one, if it's an old one, you might just have a couple of twisty knobs. 12 would be your thermostat in your room, and 12P would be like a internet gateway or something. If you've got a smart thermostat, you'll have all of these items anyway. So again, nothing new, nothing crazy outside the box. These are the high limit cutout, and then you've got a cylinder thermostat. The temperature probe on the cylinder is only a third of the way up, and so you'll see that it always displays a much colder temperature. It's not something to panic about if you haven't had a digital display before with a hot water cylinder, which once again is not unique to a heat pump. But you may look at the cylinder temperature and go, the water's only 20 degrees, whereas it will develop like a thermocline, and so you'll have cold water in the bottom of the tank where the sensor is, but at the top of the tank it'll still be over 50 degrees. Need to stop hitting the microphone. Need to stop waving my hands around like I'm Tony Blair or something. Okay. Outdoor temperature sensor 12M. Okay, so this one is, again, this is specific to weather compensated systems. This is not necessarily specific to a heat pump, but if you have a gas boiler with weather compensation, then you'll have an outdoor sensor. This takes the role of the temperature sensor that would have been in your thermostat. So if you've got a weather compensated system, sorry for teaching you to suck eggs, but ultimately a thermostat on a traditional system, as the temperature rises up, it will click the thermostat off, it will turn the boiler off, and then the temperature will plummet back down until it reaches what is called hysteresis. So it may be 1 or 2 degrees, and then it will plummet down and it will trip the boiler to turn back on, and you have up and down. And so the old school thermostat is really reactive to what's going on in the room, in the home, and it only really affects one room. So if you massively overheat that room, if you've got loads of bodies in there or cooking or whatever else it is, or solar gain, then the rest of the house could be really cold. By going to a weather compensated system, there's lots of efficiency benefits because your system can run at like partial throttle essentially. So instead of starting your car up and waiting for your engine to warm up or anything, you literally just start the engine and just go flat out down the motorway until you reach the speed limit, and then turn the car off and then let it coast until you reach 50 miles an hour, turn the engine back on, flat out. We don't drive cars that way. It's not the most efficient way to use them. It's also not the most efficient way to run a gas boiler, and it's definitely not the most efficient way to run a heat pump. So the outdoor sensor will sense every I think with the Vaillant one, I think it says it's every 0.05 of a degree. It will correct and update the flow temperature accordingly so that it's more proactive. The sensor outside knows that it's dropped a degree. It will raise the flow temperature of the heat pump so that it's feeding just the right amount of energy into the home to keep an even and constant temperature throughout. Weather compensation has been an absolute revelation for us, and low temperature heating in general, and I know that's not heat pump specific. Right, I've chatted on for way too long. Number 16 is just a rotary isolator, and number 17 is an electric meter. So this is the wiring diagram. Super simple. I was really surprised how simple this was. Basically here you can see in the main interface they split it into high voltage and low voltage, and they have bus cables can run in any direction and they can piggyback off. So instead of running you could run to the heat pump and then back over to this is the wireless gateway again, and then this is the heat pump interface. So this one is the sensor comfort in my case, and 12M is the outdoor temperature. So the outdoor weather sensor, temperature sensor. For me, 12M is wireless, so I don't have any power connection or any bus connection going to the sensor. It's got a tiny little solar panel built into it and communicates wirelessly. And so I have bus cables going to my main heat pump interface and then onto my wireless gateway. My Senso Comfort is also wireless, so that has no power or bus data cables going to it. Here you can see domestic hot water cylinder. This is post buffer pump, so I have that going. That's just the normal circulation pump for the radiators. This is secondary circulation pump, which I don't have, so that's not needed. And then this is the three-way valve, the diverter valve. So super simple, and 230 volts in, and then you've got a couple of cables going out. And the heat pump itself, you can see it just runs the bus cable. That's just a data cable, and then all you run is literally a power connection to it. Super simple. And I hope that debunks things a little bit for you. Some of the setups, if we scroll down, some of them do get a little bit more complicated depending on what system you have, but there'll be no added complexity, that's the correct word, compared to a gas heating system. If you've got two radiator zones already, underfloor heating, whatever it is, it's going to be the same. This document is a little bit harder to find now since Vaillant have jigged around all of their documents. So if you need a copy of it, just hit me a comment in the notes. I hope that kind of clarifies the layout of my system and how things work, and hopefully that kind of demystifies the complex nature, and maybe you're a little bit less terrified. Anyway, until the next video, see you again.